Hello everybody, welcome to another video in the series Python for Linguists. This is the series of videos where we do things other people can only dream of, like using Python for linguistic analysis. Um, this one is about dictionaries, the last real big and important data structure I want to talk about in this introductory sort of tutorial series. And as always, there'll be lots of code in on the slides, and also 3 different exercises. So as you watch this, please be ready to engage with these. Have your hands and your brains at the ready. I want to start by posing an initial problem. Imagine, and this is a very likely situation, it's not constructed, we have a corpus of conversations. There are speakers, and speakers take turns, alternate, sort of messily go back and forth, such as in this example here, right? Speaker, totally not constructed. D21 says, I never knew Python was that much fun. And A72 emphatically agrees, right? So the problem is, let's imagine we want to look at how different linguistically these two speakers are, not only in these 2 lines, but in everything they say in the corpus, right? How do we go about that? Problem, question mark? You might think maybe no initially, because this is similar to stuff we've done already, right? We've had our different text files in brown, and we've gone through the larger .txt files and successfully kept track of the individual text IDs within these, several text IDs being contained in one .txt file, but this rested on a very particular structure in the data that we don't have in this case. And I don't want to kind of go into much detail, mostly because I want you to think about what's different here and where the problem arises. Hence the rhetorical question here. Maybe do think for a second about this. Pause the video, figure out why what we've done so far to deal with multiple corpus texts within one file, why that doesn't work as well here. And because it doesn't work that well, we need to introduce a new way of encoding our data, and that's a dictionary. A dictionary is initially probably thought of quite plausibly as what we think of when we think of a dictionary in everyday language, where you look something up and you get a corresponding item for that, right? You look up the English word cats and your dictionary tells you that's Katzen, and is und. So I've defined a little dictionary Ingjer here that translates from English to German. Those of you who know something about these 2 languages will know that this dictionary is not 100% complete. It doesn't cover all the words in both of these languages, but it is very successful at translating precisely the one sentence, cats and dogs are animals. So if we do that, right, let's look at the structure here maybe first, right? It starts with a curly bracket, and then it's always a sequence like this. Something, colon, something else, comma. And then this pattern repeats. Something, colon, something else, comma. Something, colon, something else, comma, until after the last something, something else, here, something, colon, something else, we close the whole thing with another closing curly bracket. That's the structure of the dictionary, and it sort of probably becomes clear that there's always 2 items associated with each other. And if we want to now translate our sentence, cats and dogs are animals, into German, all we need is this little for loop here, where we look up for each word in the English original the German according to the dictionary. So let me go in here. Well, here it already is, but I'm gonna do it one more time, right? Just copy the code over. This is our dictionary, this is the sentence. We split it and use the dictionary to turn cats and dogs are animals into Katzen und Hunde sind Tiere. Isn't that amazing? If you're slightly underwhelmed, that's fine, because it's not actually all that amazing. And this is not really the power of the dictionary, but this is an example that kind of helps you see what the dictionary can, well, how it works really. You can try these things. right? I mean, we see here ing, jur, and then in square brackets word yields something, right? Cats yields Katzen, etc., etc. So you can try ing, jur, cats. What that gives you, ing, jur, cat. What that gives you, and also ing, jur, Katzen. And think about whether you're happy with that or not, whether that makes sense or not. So dictionaries map values to keys. So keys is what's on the left of the colon, values are on the right. And this is not a mapping of equal things. So whether something is a key or a value in a dictionary has a couple of repercussions that we'll look at in just a second. But it's basically kind of like a set of key value pairings. And these are separated by commas and enclosed in curly brackets. And we've actually encountered curly brackets in sets already. So this is the basic structure. And you look up the values for a certain key in a dictionary by doing dictionary and then in square brackets the key that you want to look up, like look up the value for that key. So this is similar to list indexing, and that's not arbitrary, right? This is a systematic way of kind of getting a slice of the whole data structure here. This is how you access the dictionary. What can we do with these? We can first of all create dictionaries in different ways, right? We can start by simply creating an empty dictionary, which is very often the starting point, because sometimes, and in a lot of cases, we don't know what's going to be in the dictionary at the end. So we're not going to start by defining the whole dictionary for English-German correspondences and work with that, but often it's a data structure that helps us collect information as it hits us, basically line by line by line as we go through the data. Or we can kind of spell it out. Scrabble is Scrabble values, right, in English. A is 1, B is 3, C is 3, D2, E1, I believe those are the correct values. And then we have that dictionary. So you could kind of take any word, if you fully spelled this dictionary out, take any word and have Python calculate its Scrabble value automatically. Actually could be a good exercise. I didn't kind of plan for this, but if you feel like you want an extra challenge, why not write a little program that takes any kind of word in English, maybe checks whether it's a permissible word. We have this words.txt text file, and if it is, calculates its Scrabble value. Could be fun. Knock yourselves out. You can add entries to a dictionary. So if we have an empty dict, we don't want that to stay empty. It's not very useful in its empty state, so we can kind of update things. Or we can think about our ing-jur dictionary, where we do platypus is Schnabeltier. So write everything to the left of the equal sign. If we stop there, this would try to look up platypus and give us a key error in saying that platypus is not a key in the dictionary. But if we define it, then it becomes a key in the dictionary with the associated value Schnabeltier. And we can also do ing-jur r is bist, right? You are, du bist, that's entirely plausible. But think about something, right? We already have an R in our dictionary. Cats and dogs are animals, sind Tiere. So we defined R, the value for R, to be sind. Now we do ing, jur, R is bist. What happened to the first instance of R? What happened to R is sind. Maybe try it for yourself. And then something we very often will want to do is we can get all keys or get all values in the dictionary. And that's just, those are associated methods, .keys, .values, right? It just returns, let's say, a list-like object of these values or of these things stored as keys and values in the dictionary. All right, one more slide, I think, on concepts until I'll want you to solve a little exercise. So I said there's a difference between keys and values, right? Keys have important limitations. They must be a unique set of elements. You can't have the same key with multiple values. So in case of duplicate keys, the most recent one simply overwrites the earlier ones. When we wrote ingjer r is bist, the entry ingjer r returning sind simply disappears. And they must be immutable objects. So lists, for example, can't be dictionary keys. They must be fixed and immutable objects. Those two limitations are key. And importantly, they don't apply to values. Values in a dictionary can really be anything that's kind of a Python object. They can be strings, integers, float, which is post-decimal points in a number, lists, even dictionaries, and actually dictionaries within dictionaries is a structure we'll encounter a lot. Think about this. This encodes findings we produced some weeks ago. Dictionary is called part of speech frequencies, and then we have at the top level the keys for different brown text samples, and then for each brown text sample we get a new dictionary telling us the relative frequency of nouns, relative frequency of adjectives, and of verbs, right? So for the key brown we get as a result this one dictionary. So this is the first, this whole thing is the first key value pairing. It just so happens that the value in this key value pairing is also a dictionary that includes further key value pairings, right? And then this here becomes the next dictionary entry, the next key value pairing, and so on. And this is actually a structure I personally at least use a lot because it helps keep track of a lot of things very systematically and neatly. All right, as promised, here's a yellow snake. Create a dictionary that will translate the sentence, "The quick brown fox jumps over the lazy dog," which is a pangram in English, to German. There's a German translation given in the second paragraph here if you're uncertain. Der schnelle braune Fuchs springt über den faulen Hund. So you have these two sentences, and the most tedious way would be to write a dictionary word by word. Perhaps you can think of a more clever and more economical way of doing this. And then at the level not of coding but of thinking about what this can do for us, think about what problems for automatic machine translations you get if you just use dictionaries for translation tasks. Dictionaries of the kind that we're just writing here. As always, the solution is below. Once you access the slides through the links provided at various places, you can check solutions. So pause the video here if you want some time, and I'll simply move on. Very often we'll want to iterate over dictionaries, right? We've now collected, maybe the words used by every speaker, and now maybe we want to write these to file, one line per speaker or something. So we can do for x in ingjer print x, and we can do for x in sorted ingjer print x, and here I'm also printing the corresponding value. I'm not sure this is necessary, but let's once again look at what it looks like. I get a syntax error. I don't like syntax errors. Do it one thing at a time. I think there might be something about. So for x in about line empty lines in these code snippets, this would work in a script, but I guess in the live shell you need to be a bit more mindful of the empty lines. For x in ingjer print x, right? Cats and dogs are animals. And this is the order we basically created the dictionary, so it retains that order. If we do for x in sorted ingjer, that We get and animals are cats, dogs, right? And the logic of the sorting is probably apparent. It's alphabetical according to keys, right? So those are two relatively easy things to do. The problem is very often we want to sort by values. For example, if we counted a bunch of things, maybe we want the most frequent ones, right? That's not as easy, and I just sort of spell out how to do it here. So you do for x in sorted dictionary, ingr, and then comma key equals ingr.get. So the key here, it has nothing to do with the dictionary key. That's an argument in the sorted function. So what's the criterion by which the sorting should take place? And ingr get is just basically the list of values. So it's saying sort all of this, but don't sort it as in default by keys, but by values. So let's see if this produces the expected output. Sorry, I saw I did not move back to the slides. So I'm gonna leave this sit here for just a second, right? If we want to sort by values, this is the the code that we need for x in sorted dictionary. Key is dictionary.get. And now once you've looked at it for a little bit, I'm actually going to switch back to the shell and just sort of produce the output. We get Hunde, Katzen, Tiere, sind und. And something to note, you note that Tiere and sind, that's not, it's ST, right? But it starts, I believe, with all the uppercase letters and then goes to the lowercase letters. But that's just that's nothing to do about the sort method. That's just how kind of the ordering of string characters is represented in Python. Okay. Also, something we very often need to do is to check whether something is in a dictionary. If something's a key, again, that's easy to check. We just do cats in ingr, right, and that produces or returns true because it's a key. But then Katzen in ingr, it's in there, but it's in there as a value, and for that reason it returns to false. So if we check whether something is in ingr, we strictly check whether the key is there in the dictionary. If it's a value, it can be relatively easily checked if we do Katzen in ingr dot values. So it's not really a problem per se here. All right, let's practice some more. Something a bit more applicable, less constructed. Take any corpus text that you're interested in, read it into Python, and then create a dictionary word freq that basically just compiles a frequency distribution, so the count for each word in the text. So the dictionary should basically have the set of all word types in the text as keys, and the frequency of each of these words in the set should be the corresponding value. And there's a number of ways you can do this. A general problem is that typically you encounter a word, and then you simply update the value in the dictionary, right? Word freq word plus equals 1. The problem is what to do when encountering a word for the first time. And I could think of at least two very straightforward, plausible ways of addressing this issue, and maybe you can think of one too. So pause the video here, kind of try to work through this example. Access the slides, scroll down if you want to check the solution, but do give this a little bit of time. So I think it's a quite useful exercise as they come. Okay, and I shall move on. Last thing I want to really introduce is a riff on the standard dictionary. That's the default dictionary. And as we just saw in the last exercise, sometimes we want to sort of not check whether something is in the dictionary. We just want to update the dictionary, right? In our word frequency distribution, if something's not in the dictionary, that should just get the value 1, basically. Um, and there's a data structure that's called the default dict that's in the collections module that helps you achieve exactly that. Let's see, look at what's going on here. From collections, import default dict. That just sort of gives us access to the data structure. And then we define word fricks. Normally we would, for example, just have wavy brackets, empty wavy brackets here, right? That's an empty standard dictionary. Here we define an empty default dict. So just kind of call this, and then we tell the default dict what the default value is, and it takes a kind of an object type here as a default value, and it defaults to sort of the kind of the logical non-value, right? For integers, that's going to be 0. For string, it's going to be an empty string. For list, it's going to be an empty list. So when we look up something like word fricks and then the string out of dictionary word, it returns 0, right? Even though we haven't written out of dictionary word colon 0 into the dictionary, anything that's not already in there just kind of then is conjured into existence with a value 0. So we then can do for word in my text, word fricks word plus equals 1, right? And we don't worry, with a normal dictionary, we'd get a key error here. If a word isn't already in there and we do plus equals 1, Python's going to complain. But now this works independently of the presence or absence of word in the the current dictionary's set of keys. And that's really quite handy. So basically, with this, you can rewrite the code you just produced in the previous exercise and just make it a little bit simpler. And since this is a relatively small scale thing to do, here's an additional challenge. Print the words and their frequencies in descending order. So it gives us like a list that looks like a Zipfian distribution, or well, a series of print statements, right? So printing the most frequent word, so the colon 572 and colon 246, whatever. I don't know what the numbers are, but that sort of output. And in the long tail towards the bottom, there should be all the hapaxes, all the words that occur only once. So maybe this challenge bit is the bigger part of this exercise, but that's fine. You have a small scale initial thing to solve and then something to really dig your teeth into. That concludes the session on dictionaries. Go grab those Pythons, get something out of them. I think we're very close to starting to write scripts that are able to produce publication-ready results. But I mean, obviously, the analysis kind of is another thing. But we're getting there. I'm pretty excited for all the code that you're producing and all the pretty advanced stuff I'm already seeing in the homework exercises. Here are the image credits, and here's the last slide with the QR code and the link. And that's it for today. See you soon.